So I think we had done this question, right? And what I'm going to do is I'm going to share with you a chart. Where's WhatsApp? Just a second. Okay, so it's just going to be a division chart for organic chemistry, which we're going to be referring to. Okay, I've shared it in the WhatsApp group. So most of the organic chemistry is summarized in these 3-4 pages with the marking schemes. So we're going to move to question number 22. Which statement is not correct? So combustion of PVC produces highly acidic gases. Is that true?
Yeah, carbon dioxide.
No, that's not a highly acidic gas.
It's not highly acidic.
I mean, carbon dioxide is an acidic gas, but it's not very soluble, so uh, it doesn't really produce a strong acid. I mean, like we breathe out carbon dioxide. It's not really highly acidic.
Yeah.
So, I mean, it's very slightly soluble, so it might dissolve in water, but very, very slightly. And in that case, it might produce a very slight acid. That's it. But anyway, so it's not highly acidic. What gas could be highly acidic? Like what chemical compounds does PVC have?
It has a carbon with 2 hydrogens and a carbon with a hydrogen and a Cl.
Yeah, I mean, it actually has chances of producing HCl gas when it burns. The hydrogen and Cl can combine. Uh, so that is a possibility, but we'll come back to this one. Um, if we could, what about the other ones? PVC molecules are saturated. Is that true?
Yes.
The empirical formula of PVC is the same as the empirical formula of its monomer.
It's the same.
Yeah. The repeat unit of PVC is this.
No, this is wrong.
Yeah, that's definitely incorrect. So that's definitely incorrect. So that kind of means that the HCl possibility wasn't really there. Okay, so that means it doesn't really produce highly acidic gas. Is that clear?
Yes.
The presence of halogen in an organic compound may be detected by warming the organic compound with silver nitrate. Silver nitrate produces a precipitate with halides. Which compound would be the quickest to produce a precipitate?
The one with iodine.
Okay, so that's C. Halogenoalkanes react with NaOH in an SN1 mechanism or by an SN2 mechanism. The mechanism followed by the reaction depends on the structure of the halogenoalkane. So you've got 3-bromo-3-ethyl pentane. First, tell me which mechanism is it going to be?
It's tertiary, so SN1.
It's SN1, right? And why does it follow the SN1 mechanism?
It's not A because it's not an anion, it's a cation.
It's it?
Cation.
That's pretty obvious. So it forms a very stable intermediate cation because it's got 3 alkyl groups which are electron donating. Now, which compound is a secondary alcohol that can be dehydrated to form an alkene with an MR of 70? So secondary alcohols, which ones are secondary alcohols?
A is not a secondary alcohol. B could be.
Yeah.
C as well, and D, yeah.
So it's going to produce, so all 3 are secondary alcohols. So it's going to produce an alkene with an MR of 70. Which alkene is that, by the way?
It has 5 carbons, I think. So it's pentene.
Yes, C5H10. Not really pentene because it could be branched as well.
Yeah.
So
It can't be C because C has 4 carbons.
the others have 5, right?
Yeah.
So which one out of these two?
How do you figure it out?
I mean, the OH is going to go and it's going to form an alkene, right? Either to the right or the left side. This OH is also going to go and it's going to form an alkene. Is that clear?
Yes.
Either to the right. I mean, in this case, it doesn't really matter. It's going to be the same thing. But over here, it's going to be two different alkenes. Actually, yeah, two different alkenes. Either double, but it doesn't really matter. We're just looking at the whole formula. The formula would come out to be the same. But remember, it can't be cyclic. It's not going to be cyclic. Why? Because, I mean, you can either count the atoms and see whether it matches, or you should know that this is the general formula of an alkene, right?
Yes.
But this is a general formula of an alkene that is not cyclic. Whenever you have a cyclic compound uh, in any cyclic structure, there would be 2 extra hydrogens that are going to get removed. Like you can count the H's. I mean, this one would be C5H10. That's 1, 2, 3, 1, 2, 3 H's on this. 1, 2 H's on this. I guess there's going to be 1 H on the middle one, and there's going to be 1 H. I mean, this OH is gone. That carbon is still short of 1 bond, so there's going to be an H over there as well. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is the one, right?
Yeah. It can't be cyclic.
It can't be D because either you count it, that's 1, 2 over here, 2 H's here, 2 H's over here. And I guess this one is going to have 1 H, right? So if you count it, it's going to be 1, 2, 3, 4, 5, 6, 7, and 8 H's. So just remember that it should have had 10 H's, but since it's cyclic, whenever you have a cyclic compound, two further H atoms get removed. So it was never going to be, the general formulas only apply to aliphatic, not aliphatic, but branched non-cyclic structures. Is that clear?
Yes.
The other 1.0075 moles of an alcohol X are completely burned in excess oxygen and gases produced are passed through an excess of lime water. 3 grams of calcium carbonate are produced. And when X is bound with potassium dichromate 6, there's a color change from orange to green. First thing, which of these compounds can you eliminate? I mean, it's getting oxidized, so
It can't be a tertiary alcohol, so it can't be B.
because you got a primary, you got a secondary, you got another secondary. So it's all these 3 compounds. So will you be making a complete equation, or can you do this without an equation?
Can you do it without an equation?
Yeah, because you're only interested in carbon dioxide, right? I mean,
Yeah.
complete burnt and the carbon dioxide produced, right? So you can figure out the carbon dioxide without the equation. The first one is going to produce 1, 2, 3, 4 carbon dioxide molecules, right?
Yeah.
The C
The
is it's going to produce 3 carbon dioxide molecules.
five. And D also 3.
So tell me the moles of carbon dioxide produced. If the first one is 0.0075, so this is going to be
Then times 4. It's 0.03.
and what's moles, right? And times
Times 3, it would be 0.0225.
0.0225, right? I'm going to
Yes.
eliminate C and D anyways because they're going to eventually give the same answer because it's the same amount of carbon dioxide that's being produced, right?
Yes.
And that carbon dioxide is getting converted to calcium carbonate, right? Carbonate, 1 second, 3. So if it's getting produced, so one carbon dioxide will produce 1 calcium carbonate, right?
Yes.
So 0.03 is going to produce 0.03. And the amount of this is 100. So that's going to give you 3 grams, right?
Yes.
But I was able to eliminate C and D anyways because they were going to eventually give the same answer. So that would have not been possible. Now, considering only structures, what is the number of alcohols of each type in the formula C5H12O? Try and draw this and tell me what the answer is.
Okay, one sec. It could either be 5 carbons as a straight chain, or 4 carbons in a straight chain and 1 methyl branch on the first or second carbon, so that's 2 structures. Or it could be 3 carbons and
Let's start with the 5 carbon atoms in a straight chain. How many different alcohols can that produce? It's alcohols,
it
right?
can alcohols, yeah. It could have OH on the terminal position,
Okay.
or it could be on the second or third carbon.
So that's 3 possibilities, right?
Yes.
What about the other one? In this case, it doesn't really matter whether it's on the second or the third.
Or yeah. It could be in the terminal position, or
The
it could be, yeah, it could be on the terminal position,
okay, so that's 1.
or on the carbon with the methyl branch,
That's
the
2.
second. Third would produce a different structure, right?
Yeah, because it's asymmetric, right? So
Yeah, I think that's it. No, the
Yep.
fourth one as well.
yeah. So H over there. This one would be exactly the same as this one, right?
Yeah,
I mean, there's no point. I mean, this you add it over here or add it over here. It's the
it's
exact.
the same.
So then you have
So there's 2 primary, not 2. There's 3 primary.
then you're seeing okay. And what about the last one? That's how many different positions can you attach the?
It's only on the terminal position.
Yeah, that's it. The only one, right?
That comes 4 primary.
Okay, so that's this is primary. These two are secondary, right? This is
Yes.
primary and this is primary and this is tertiary and this is secondary and primary, right? Yeah, so 4 primary and you've got 3 secondary.
So it's C.
So there's a 2-state synthesis, this getting converted to this, right? So which compound, so how do you go from this to this?
What's it called? You convert it into a cyanide, a nitride, and then you perform hydrolysis. So it's D, right?
D, because there's going to be an extra carbon. So there's an extra which has a structural formula of the ester is given. X can be prepared by heating alcohol Y under reflux. So you basically have to figure out what the alcohol is.
Okay, so if it's ethanoic acid and we have 6 carbons, so it has to be an alcohol with 4 carbons. They're all 4 carbons already. There's no such, wait. Butan 3-odd is not a thing. Is it?
Yeah. I mean, you can draw this. It's 1 carbon, then there's the ester group. Then there's a carbon within H, and then there are two carbons, right?
Yeah.
So your alcohol is this thing, right?
Yes.
Just give me one. So which one is this?
That's is that butan 2-ol?
Butyl 2-ol, right? Yeah. Okay, that's butyl 2-ol.
Yeah.
And next one. Compound S can be extracted from natural compounds reacting as with hot concentrated cheminophore produces the organic compound D. So hot concentrated cheminophore, right? And it forms a compound D. Some of the observations found in the infrared spectra of SMT are described. So S has a strong absorption between this range 16. What does this represent?
It's a carbonide, C-double-bond-O.
Yeah, so that's a acetyl bond O. And D has a strong absorption at it's got a carbonyl as well, right?
Yeah.
And but no strong absorptions between 2500 and 3000. What does that mean?
So it's not an alcohol.
Uh, not an OH group, basically.
Yeah.
I mean, 2500 to 3000 is basically an OH that belongs to a carboxylic acid.
Yeah, so it can't be a carboxylic acid.
No, but it's got a, it's, so that means it's a carbonyl as well.
So it formed a ketone. It got oxidized into a ketone, the alkene.
Okay, so sorry, the first one, S does not have this, right?
Yeah.
While D has this, right? So it's forming a key. So which is S and which is T?
Here. So T can't be A because that's a carboxylic acid.
Yeah, just one second. So which one is it?
Is it B?
That is a
Because
key.
we can
Yeah, it is a
we
key.
can eliminate D because T has a carboxylic acid group, so D can be
Key
eliminated.
is the only thing that's produced, or
Um,
he says I think what he's saying is that is it only producing T or is he producing something else as well? I mean, I think it's vague about that. He's just saying that, yeah, we don't know. So let's focus on this one.
it
So now,
can be done by elimination because it can't be A or D because they have carboxylic acid groups for T.
yeah, so that's automatic. They're not going to form carbonate, right?
Yeah.
While
And
while this one will
C
form,
also,
C will form ketones. C will form ketones.
but it has a carbonyl group. S has a carbonyl group in C.
Oh yeah, needs that's not a carbonyl group. Is it a carbonyl
It's
group?
not?
Nee, it is a carbonyl group. Yeah, it is.
Oh.
Uh, so this one is definitely. So I think it is B. What was wrong with A? That A is automatically eliminated. C has got a
Because
carbonyl group,
carboxylic acid.
and D is going to form. I mean, it's got a carboxylic acid group. I mean, you could have just done this anyways. You were not supposed to have carboxylic acid, right?
Yeah.
So that's fine. You're not supposed to have ketone over here. You're supposed to have ketone over here, and you're not supposed to have carboxylic acid anyway. So it's going to be B. That's the only option. As the next one, we complete combustion of hydrocarbon gives 0.132 grams of carbon dioxide and 0.054 grams of water. Which formula could correctly represent this hydrocarbon?
We have to find the number of moles of carbon dioxide and of water.
So how many moles do you have?
So there's 3 times 10 power negative 3 of carbon dioxide.
Okay, so carbon dioxide is 3 times.
10 power negative 3.
So that means carbon is going to be exactly the same as well, right?
Yeah.
And water as well. So water is 0.054
It's
divided
the
by.
same number of moles as carbon dioxide.
So water is 3 times 10 power minus 3, right?
Yeah.
Means one water has 2 H's, so the amount of H will be double the amount, right? So it's going to be 6 times. 6 times, right? Is that clear?
Yeah.
So the amount of carbon and the amount of hydrogens, that's 1:2. So in that case, it can be all 3.
Yeah. So it's A.
So it's A. All 3 are possible. Next is we've got which statements are correct. Magnesium carbonate decomposes at a lower temperature than calcium carbonate. Is that true? What happens to the decomposition temperatures?
It increases down the group.
Yeah, so the first statement is true. This will be easier to decompose, right?
Yeah.
Calcium hydroxide is more soluble in water than magnesium hydroxide. What happens to the solubility of hydroxides down the group?
It increases.
So that means that's true. That's true, right?
Yeah.
Calcium is a stronger reducing agent than magnesium.
Yeah.
Reducing agent gets oxidized. So who's going to lose electrons? Calcium would lose electrons easily because why? Because it's a bigger atom. Down the group, it becomes easier to lose electrons. So that is also correct. Now, what happens in this? I mean, I think it's a redox reaction. It says nitrogen atom oxidized.
Yeah, the oxidation state increases from wait, no, it decreases. It goes from -3 to 0, so it decreases, so it's reduced, not oxidized.
What's that reduced not?
Is nitrogen reduced?
No, it's oxidized, right? It was -3 over here and 0 over here, right?
Oh yeah, it's oxidized.
So that is true. It does not change. I mean, it's still -3 over here. So so this is actually wrong, by the way,
Why is that wrong?
because not all of them got oxidized.
Oh, it said each, so it means both.
So each chlorine atom is reduced.
Yeah.
So that is true. All of them got reduced, right? And ammonia behaves as a base, which it is behaving because it is accepting H+1 ions. It became NH4+1, right?
Yeah.
So then you have diagram shows the reaction pathway for a reversible reaction. So which statement are correct for a reversible reaction? Forward reaction is exothermic.
Which is exothermic.
And enthalpy change for the forward reaction is -30, so that's true.
Yeah.
Backward reaction, the enthalpy change for the backward reaction is +90.
Isn't that the activation energy?
Yeah, that's the activation energy. It's going to be +30. It's just going to be the opposite of this. You go from this to this point. Next one, the structure of metals is considered to be positive ions surrounded by delocalized electrons. Melting points of the metals in period 3 increase with increasing atomic numbers. Which statement explains this trend? So sodium to aluminum, why is the melting point increasing based on the metallic structure?
First one is correct.
Okay, so you got more charge.
Yeah. More delocalized electrons is also right.
So more negative electrons, so there's more attraction.
And across the period, the radius decreases. So 3 is also right.
Oh, sorry, that's
Is it? Yeah.
true. Under room conditions 600 cm cube of gas, X has a mass of 0.7 grams. Room conditions, right? Can you tell the MR of this thing?
Number of moles would be the volume divided by 24. And we have to convert the volume into decimeter cube.
Yeah.
No, we have to find and then we have to find the MR.
Yeah, you'll find the moles, which is, I think, 0.25 moles.
Yes, it's 0.025.
Okay, and you got the mass as well. So mass divided by moles is MR, right?
Yes.
So
It's
what do you
28. So it's nitrogen. And can be carbon monoxide too.
Can be all three actually.
Yeah.
They all have the same MR. C2H4, that's 12, 12, that's 24, plus 4, that's 28 as well. And nitrogen is obviously 28. So
Yeah.
which compound on reaction with NaBH4 forms a compound with a chiral carbon atom? It's a reduction that's happened.
The first one, it produces a secondary alcohol. So it does it's chiral, yeah.
So it's 1, 2, 3, 4, 5. So the carbonyl turns into an alcohol, which is going to be chiral because
Yeah, all of them, I think, because they're all ketones.
the second one will not.
It won't?
I mean, the second one, let me just check. Second one, it's 1, 2, 3, 4, 5 carbon atoms again. The middle carbon, which was carbonyl, will turn into an alcohol. This will not be chiral because
Yeah, because it's symmetric from both sides.
right and left side are exactly the same. So that's not chiral. And the same applies to the last one as well. That's not chiral. Because
So it's one.
it's a one only. So then you have compound Y is a straight chain molecule with this formula. It's a halogenoalkane. The MR of Y is 137. The halogen atom is on the second carbon atom in the chain. So it didn't really tell us much, but it contains a chiral center. So 137. Can you think of? I mean, you can actually guess what this compound is.
Might have like 7 carbons.
Is that possible? Like, what is the halogen then?
Is it bromine?
So bromine alone is 160, right? I mean, what's the it's 80, right?
Yeah,
So 137, the MR of Y is 137. So 80. So what are you left with? 57.
57, yeah.
So for 57, you would need let's say you got 4 carbon atoms, right? That's 48. And 48 plus 2n plus 1, that's 9. So that's 48 plus 9 is 57, right? So it can
Yeah, it adds up to 137.
and you said it's a straight chain. You didn't really tell the position. It's on the second one, right?
So in that case, it is chiral, yeah.
But can it be any other halogen? Like, it can definitely not be iodine. I mean, 108, it can't be 108 because 108, that's, what are you left with? That's 29.
Yeah. It can't be iodine.
Can 29 be CnH2n plus 1? That's, it can be iodine actually. Like C2H5, I.
But it said it's like the second carbon atom on the chain. The chain would only be 2 carbons long.
Yeah. So it can't be on the second one. It will always be on the first one.
Yeah.
So that can't be right. Can it be chlorine if I have, but chlorine can be 35 or 37. So if I have 30, 102, that will be what? What's 8 carbon atoms? 12 into 8, that's 96. 96 plus, no, it can't be. Like if I have 8 carbon atoms, then H's would be 2n plus 1. That would probably not happen. But anyways, I don't think it will matter anyways because I mean it can't be iodine, so that's out of the question. But even if it is chlorine, this one Y can eliminate HX to form two structural isomeric alkenes. That's true because the double bond could be over here or it could be over here. So that is two structural isomeric alkenes, right?
Yeah.
And Y can eliminate HX to form two geometrically isomeric alkenes.
The last one has 2 hydrogens, so it can't form cis trans isomer.
Okay,
The
so
first carbon.
this one will not, right?
Yeah.
So even if it had been chlorine with a longer chain, it will, I mean, this scenario would still be the same. So it doesn't really matter. The first two will be correct, but the third one will not be correct, right?
Yeah.
So then you've got propanone and HCN react together by the mechanism shown. This is nucleophilic addition. So which statement of this mechanism is correct?
It's a nucleophile, it's not an electrophile.
Yeah, that's wrong.
So if one is wrong, then it's only 2 and 3.
Yeah, it's an addition, nucleophilic addition. And all the bond breaking is heterolytic, right?
Yeah.
Which is the only reaction where homolytic bond fission happens.
Free radical substitution.
Because that's free radical substitution. Then there's the organic compound with the molecular formula C3H4O. It is used in water treatment and as a herbicide when acetylene reacts with 2,4-DNPH. And orange, what is this? What does this mean?
It has a carbonyl group,
And this what?
so it's an aldehyde.
So it's an aldehyde. Which statements are correct? So it's a 3-carbon atom aldehyde, right?
Yeah.
You can't really have any branches in this. So is this?
And just not negative iodoform test.
Nee, but tell me, is this the formula? It's not this, right?
No,
Uh,
because it has more hydrogens.
so there must be a double bond, right?
Oh,
So
yeah.
that will get rid of 2 H's. So
So
now,
now it's okay.
now it's all right. So it can't react with it won't have an iodoform test, right?
Yeah.
For that, you need a methyl group next to a carbonyl, so that's not possible. And can be reduced to a primary alcohol. Aldehydes are produced from primary alcohol, that's true. And
It
bromine,
has an alkene group, so it can decolorize.
yeah, it's going to react with bromine as well. So we can start with the next paper. Let me just see if we can. Then we can do some questions from this one, and I'm sharing this one. So this one is summer 22, right? So my laptop. This one's with me. Look at this one. Let's start with the first question. Sodium azide is explosive used to inflate airbags. What are the number of electrons in the sodium ion and the azide ion? Can you hear me?
Yeah. Sodium would be 10.
And what about azide ion?
Azide ion. Is it 20?
Azide ion is 20, yeah. Because 7 electrons and that's multiplied by 3. Plus it's going to have a -1 charge. So it's going to be 22. I mean, this is like Na is always +1, right? So that means N3 will be -1, right?
Yeah.
So 7 electrons each. So that's 21. Minus
So it's 20.
22, right?
No. Yeah.
So then you have U's are not the actual symbols of the elements. Which statement about the elements is correct?
P and X are in the same period? Not necessarily.
I mean, they're definitely not in the same period because this is one
Yeah.
period and that's your next period, right?
Yeah.
They're in the same group though.
Because they're the peak of each.
So basically, they're noble gases, right? That's group 18.
Yeah.
Why do the atomic radiuses increase across the period?
It decreases. So it's not P.
It
atomic radius decreases across the period.
What about the next one? Why is
It's
there
not,
why is there
it's
a dip?
increase.
Let's see.
Is it D?
Okay, that's definitely spin pair repulsion because U to B, that's group 5 and 6, right?
Yeah.
So that's because of paired p orbitals that repel each other, so it becomes easier to remove electrons in V, while in S, there's increased shielding. That's like when you move towards group 3, you get an extra orbital, which increases shielding, so it becomes easier to remove electrons. So this one is probably a slightly tough one. Can you try and solve this one?
Okay.
Basically, I guess you have to construct a balanced equation.
Is it C?
C, no, C is what is the equation that you got? I mean, say Al4C3.
Al4C3 plus 4NaOH
See, I'm going to balance
plus
the
and two,
react readily. Water molecules are also involved as reactants, right?
yeah. And it produces NaAlO2
And a hydrocarbon.
and
Let's call it CXHY. So if I balance it, there are 4 Als on the left side, right?
so it would be 4NaOH.
So there's going to be 4 anyways, right? And can I balance the O's? I can balance the oxygens, right? How many oxygens do I have on the right side? That's 8, right?
Yeah.
So there are 4 already over here. So there should be 4 oxygens, right?
Oh yeah, 4 oxygens.
Now I'm going to come to carbon and hydrogen. So there are 3 carbons. So what is this X going to be? There should be 3 carbons, right?
Yeah.
And how many H's? How many
You
H's?
have 12.
So there should be 12 H's, right? So this is the hydrocarbon, right? C3H12, which is which one?
Um, is it like CH4, but then it's like 3CH4?
Yeah, so basically you just need C3H12. So one way of getting there is if I have 3 CH4s, so I'll get C3H12.
Yeah.
So just the next 2 questions. A sample of 35.6 grams of sodium carbonate contains this much sodium ions by mass. When this sample is heated, sodium carbonate and water formed, what mass of water is given off? So again, that's a slightly tricky one. Sodium carbonate with a certain amount of water in it, right? And he has given you the mass. He's actually told you that the mass of sodium in this. The percentage, that's 25 point. That's 25.84%. By mass, right? Can you find out what X is? Basically, he's asking you to figure out the water, right? I mean, you can, how do you find out the percentage of sodium? That's the mass of sodium, that's what, 46? Divide by the total,
Yeah.
which is 46 plus carbon is 12 plus 16 times 3. Plus there's X amount of water, right? So that's X times, what is water? That's 18. And times 100, the percentage should come out to be 25.84. So you basically just have to solve this. And you'll find out what X is. Can you find this out?
Is it C?
Yeah, so for this one, 14.4.
Wait, no.
Now that will give you the value of X basically. In there, see.
I tried doing it by like trial and error, but I'm not sure.
Nee, but why not this way?
I don't know, I just got confused.
Nee, but did you get this part right? The thing that I did.
Yeah, I did.
I mean, you know that this is 25.84%, right? So I tried figuring out the
Yes.
percentage. It's 46 divided by the whole thing, and it gave me this, right? So let's say this is 0.25. Let me, since 46, what's the whole thing? What is this? That's 106, right?
106 plus 18x.
So 106 times 0.2584 plus 18x times 0.2584, right? So if I try to solve for x, it's 46 minus what, 106 times 0.2584, and then the whole thing gets divided by what, 18 times 0.2584, and that's equal to x, right?
Yeah.
So why is it coming out to be a negative? Is it
I
coming up?
got it as
Is it positive or what do you get?
I got 4.
So you got 4, right?
Yeah.
Okay, so I'm just trying to figure out what's the shorter way of doing this, but it's taking a long time. As anyway, so you got 4. Now you can find the percentage of water. I mean, you can figure out now you can figure out the percentage of water over here in this. So in all of this, in 35.6 grams, what is the mass of water that's going to be given off, right?
So we can find the number of moles of the hydrated sodium carbonate.
Yeah, so you got 4 water, right? So 4 water is what, 18 times 4. So
Plus 106.
so divide by 106 plus 18 times 4, right? So that's the
Yeah.
total. So and the mass is what? The mass is
The
35.
mass is
What do you get?
14.4.
I think you're getting C. It just took a very long time. That's what I'm.
Yeah.
Um, I mean, C is the right answer, but what could be an easier way of doing this? It's yeah, trial and error would have been kind of easier if you. Yeah, that could have been easier if no, that wouldn't have been easier. That would have. I think there's no shortcut. I mean, this was the only way of doing this, but you get the idea, right?
Yes.
Because the trial and error it would have been harder because you had to do one thing and then you had to do the other thing. So that would have taken a much longer time as well. Because you would start with the first one, the second, then third, so it's going to take a longer time. I said, what happens when AlCl3 sublimes? Which is the formula for AlCl3 subliming?
It's A.
Yeah. ठीक है. चलिए, Judy, we can continue with the same paper tomorrow.
Okay.
Okay then. Take care. Allah Hafiz. यार आवाज अच्छा यार आवाज आ गई.
जी सर.
अच्छा मैंने नहीं कोई चीज अगर पढ़नी हो ना आ भी जाना ठीक है. हाँ.
जी सर.
मैंने कहा कोई चीज अगर पढ़नी हुई ना स्पेसिफिकली तो घर आ जाना बेशक ठीक है.
जी सर. ठीक है.
चल ठीक ओके.